Page 2 of our second semester geometry exam review. So, first one says find the area of each. Use your calculator's pi button. Round your answer to the nearest tenth. Okay. Well, we want to find the area of a circle. I have some area formulas over here that you need to know, and we'll be using those. We'll go ahead and bring up a calculator. It says use the calculator's pi button, so we will get to that. And, well, we want to find the area of a circle. So over here, we know that the area of the circle is pi times the radius squared. So area is equal to pi times the radius squared. What is the radius? Well, the diameter is 9, so the radius is half of that, so that's 4.5. So we have pi times 4.5 squared is 20.25. And then we're going to multiply that by pi using our calculator's pi button. So area equals that 20.25 times pi. And we get 63. Round your answer to the nearest tenth. So 63.6 inches squared. That's the area of a circle that has a diameter of 9 inches. Find the area of each sector. Okay, well, the area of the sector over here is theta over 360, which is the central angle over 360, times pi times the radius squared. So it's just a fraction of the area. This 120 is indicating this angle is 120 degrees, so the area of this sector, just rewrite the formula here, theta over 360 times pi times the radius squared. Well, that's 120 over 360 times pi times the radius, which is 11, squared. And we can work our way through this. 120, that actually reduces to 1/3. So you can just put 1/3 or 1 divided by 3. You can do 120 divided by 360. We know it's going to be 0.3 continuing, so 0.3, we'll just put several of them, times pi, we're going to use our calculator's pi button, times 11 squared is 121. Or we can just type this in there, so 0.33333, that's enough, times pi times 121. And the area is 126.7. This is in centimeters, so the area is in centimeters squared. Number 14, that's a triangle. We know that the area of a triangle is 1/2 base times height. So area equals 1/2. Base and height are always perpendicular. So if 11 is the base, 8.6 is the height. Well, we'll go over to our calculator. We know 1/2 is just 5/10 or 0.5. So 0.5 times 11 times 8.6. Our area is 47.3 feet squared. And our last area one, this is a parallelogram. So you might end up seeing a few other ones in here, but so far we've done parallelogram, triangle, and circle. So area of a parallelogram is base times height. Well, base and height are always perpendicular, so 1 is the base, and 1 is the height, which is 1. Yards times yards is yards squared. Moving on to our next group, find the missing side of each triangle. Leave your answer in simplest radical form. We'll do both. We'll look at the radical form, but we'll also look at decimal form. So these are right triangles. So we know in a right triangle, we can use the Pythagorean theorem to find a missing side. It's always a leg squared plus a leg squared equals the hypotenuse squared. So 7 is a leg, 10 is a leg, and the hypotenuse is x. So this is 49 plus 100. 149 equals x squared. And we take the square root of that. So x is the square root of 149. I don't really think 149 simplifies it all. So that's simplest radical form. If you want to see it as a decimal, you can just put it in your calculator. So the square root of 149 is 12.2. So simplest radical form is the square root of 149, decimal approximation 12.2. Over to this one, Pythagorean theorem obviously can be used for 16 and 17. Here, one of our legs is 6, so 6 squared, plus the other leg is x, so plus x squared is equal to 11 squared. We multiply those things out. We're going to go ahead and subtract 36 from both sides. (121 minus 36 is 85. We take the square root of both sides. And once again, this one, you can't simplify the square root of 85. 85 is 5 times 17, and neither of those are perfect squares. You could also type that in your calculator to get a decimal approximation. 9.2. These are in inches. And the last one, I didn't put the units. These are yards. And our last 4 questions from this page have to do with 30, 60, 90 triangles and 45, 45, 90. There's the formulas that we learned. And so that's what we're going to be using. We're supposed to find the missing side lengths. So for number 18, this is a 30, 60, 90, and we know the hypotenuse. So the hypotenuse is 2 times the short leg. So what does the short leg have to be? So the hypotenuse is 2 times the short leg. I'm going to do some abbreviating here. Well, the hypotenuse is 3. You may have already figured it out, but divide both sides by 2, and the short leg has to be 3/2 or 1.5. So y equals 1.5, and I probably should have just put y in here earlier. So y equals 3/2 or 1.5. But we know the long leg over here is the short leg times the square root of 3. So the long leg, which is x, long leg, is the short leg times the square root of 3. Well, in our case, the long leg x is the short leg, 1.5 times the square root of 3, and that is good enough. You also might see 1.5 is 3/2, so another way you might see it is 3√3/2. All right, number 19, still a 30, 60, 90, and we know the short leg. So if we know the short leg, we actually can easily find both other things. So the hypotenuse, go ahead and zoom in so we can see this, because I'm going to be writing smaller. Hypotenuse equals 2 times the short leg. Well, the hypotenuse is x, the short leg is 3/2, and so therefore we know x equals 3. And then we know the long leg equals the short leg times the square root of 3. Well, the long leg is y, And that equals the short leg, which is 3/2 times the square root of 3. And we're done. In fact, number 18 and number 19 are the exact same triangle. I apologize for putting the same thing on there twice. All right, 20 and 21 are 45, 45, 90s. We have our little key over here. Hypotenuse equals a leg times the square root of 2. Well, in a 45, 45, 90, legs are both the same. So these two have to be the same. So y is also this 3 root 2 over 4 because the legs are the same. And then we also know the hypotenuse is a leg times the square root of 2. So the hypotenuse in number 20 is x, a leg, either one, they're the same, is 3 times the root square root of 2 over 4 times the square root of 2. Well, we can simply put this over 1, and we get 3 times the square root of 4 over 4. However, what's the square root of 4? That's just 2, so 3 times 2 over 4, we get 6/4, which is 3/2. So x equals 3/2, y equals 3 root 2 over 4. And our last one from this page, and this idea of these special triangles, is 21. And let me just slide over because we have a formula right here. We know the hypotenuse, which is 6, is equal to a leg, which x and y have to be the same. So we'll just pick x times the square root of 2. We can divide both sides by the square root of 2. So x equals 6 over the square root of 2. It's not technically proper form, so we multiply both sides by root 2 over root 2. Because we're not supposed to have a square root in the denominator, we get 6 root 2 over root 2 times root 2 is root 4, which is 2. And then 6 and 2 do reduce because they're both outside the radical. And so x turns out to be 3 root 2. Page 2 complete.